Up until now, we've talked about constant velocity, which means that we look at a graph like this, a position time graph. We see an object that starts with an initial position, travels away from that initial position with a constant positive velocity, then changes direction and moves back towards the initial position with a slightly slower negative constant velocity. And constant velocity works great in a lot of different situations, but in the real world, things just don't always move quite like that. So let's consider what has to happen for that change to occur. The object has to slow down. It then has to change direction. And then it has to speed up in the opposite direction again. Anytime one of these three things happens, we call that acceleration. So how do we describe acceleration? Well, in the acceleration lab, you're going to do two things. You're going to first measure the acceleration of your cart as it rolls down the ramp. Just like that. To do this, you're going to need a cart with a piece of plastic in it called a picket fence. You're going to need 2 photogates, and the photogates are going to be our stopwatch. Remember in the pendulum lab when you had to start and stop your stopwatch to measure the period of the pendulum? And that was hard to do because it was hard to tell during the swing exactly when to start and stop that stopwatch. And so you had a little bit of what we call human error in that timing. The photogates instead use an infrared beam. So every time the beam is broken, the light flashes, and if we can set it up to start the stopwatch, start the time when the first one is broken, and stop the time when the second one is broken, and it'll measure the time for the cart to travel to this position. You're going to need to mark the starting position at your first photogate. That would be 0. You'll need to place the second photogate about 10 or 15 centimeters down the ramp in front of the first photogate. You'll then set up your lab quest to time how much time it takes for it to travel from 0 meters to your first position, which is about 15 centimeters away, or 0.15 meters away. Now you'll have to adjust these photogates so that it is just reading the top of the picket fence. Then you're going to move, you're going to record that time, you're going to remove this second photogate about 10 centimeters down the track. Again, you'll have to adjust the photogate so that it is still, the beam is still being broken by the top part of that photogate, and you have to watch those wires, make sure that they don't interfere in the motion of the cart. And then you're going to repeat the experiment. You're going to record the time it takes to get to the second position. Move it about 10 centimeters down again. Repeat. You should probably do 2 trials for each position of the second photogate so that you know that you're getting pretty consistent, pretty precise results at each position. If you're not, then there's something probably wrong. A few things that can go wrong: these tracks have a little groove for the wheels to sit in. And if you accidentally get one wheel out, they will still roll down the track, but not as fast. So that can be one interference. Another problem can be the cords can get in the way and cause you a problem. So that's the idea for measuring the acceleration. We're going to measure how much time it takes for the cart to get to each position as it goes down the track. And then we're going to make a position time graph of that motion. Your second task in this lab is to then compare the acceleration of your cart and the motion of your cart down the track to another group's cart, and to see what other factors can affect the acceleration of the cart. For example, does the mass of the cart affect the acceleration of the cart down the ramp? Or how about the angle of the track? Or whether you have the aluminum track or one of the plastic tracks. So we're going to not only measure the acceleration of the cart down the track, but we're also going to compare our accelerations with another group and talk about the factors that might affect the acceleration of the cart.